Okay, so I'm back again, and in this video we will learn how to change complex numbers into the modulus argument form. And remember, it's basically converting a point in the Cartesian coordinate system into a point in the polar coordinate system. And I hope you still remember there is a connection between every point in the Cartesian coordinate system with the points in the polar coordinate system. If you don't know this connection, I'll recommend you pause this video and watch my last video first. Okay, we'll move ahead. So, as we discussed in the last video, this is the connection between the points in the polar coordinate system and the Cartesian coordinate system. Okay, so we have to move ahead. Okay, now take a look at this. This is the polar coordinate system, and I hope you remember we call this point as pole, and this is the initial line, and the red dot is a point on the plane. Okay, so this red dot, as you notice, it is above the initial line. And always remember, when we convert a complex number in the Cartesian system to the polar coordinate system, the angle should be maintained between minus pi and pi. So normally what we do is, whenever we have a point above the initial line, that means in the Cartesian system, it will be either in the first quadrant or in the second quadrant, we will go for the positive angle. That means we will move in the anti-clockwise direction. But if we have a point like this, if we have a point below the initial line, okay, I'll join it. Okay, so this is our R, and whenever the point lies below the initial line, what we do is we go for the negative angle. That is, we will move in the clockwise direction, so that we will be able to maintain theta between minus pi and pi. Okay, and there is a trick. It will be very complicated if you try to calculate theta without this trick. So what I usually do is, first I find the positive angle, in the sense I will make sure x and y are positive. So remember, we have a complex number x plus I y, and x is the real part and y is the imaginary part. So what I do is I'll calculate something called phi. Okay, it is pronounced like phi, phi. Okay, so what I do is I'll calculate phi, and that will be tan inverse of modulus of y by x. And modulus means you have to take the positive value of this part. Okay, and once I calculate pi, I'll be able to find theta very fast with this method. If your complex number is something like 3 plus 2i, okay, 3 is positive, 2 is positive, so basically this complex number lies in the first quadrant, and the first quadrant theta will be equal to 5. Now imagine your complex number is something like minus 3 plus 2i, and that means you're going to have a negative and positive. That means your complex number will be in the second quadrant, and in the second quadrant the value of theta will be pi minus 5. And this is the case when we have the complex number in the first quadrant or second quadrant, or just above the initial line. Now if it is in third quadrant or fourth quadrant, just take the negative value. That means it will be minus 5 over here, and it will be minus of pi minus 5. Okay, now take a piece of paper and pen. Okay, you can pause the video for a minute, go for a piece of paper and pen. So remember, this is what you are going to find. So you can start noting down. The given complex number will be in the Cartesian system, so it will be in the form x plus iy. Do you remember the transformation? X is equal to r cos theta. So we get r cos theta plus I times r sin theta. Okay, so z will be equal to r into cos theta plus I sin theta. So remember, this is called the modulus argument form, and we calculated the value of r. Okay, so we have r is equal to root under x square plus y square. If you're still not clear how we got this value, you can pause this video and watch my last video, where we derive the connection between Cartesian system and the polar coordinate system. Okay, so once more I'll explain. We have a complex number z equal to x plus iy, and clearly it's a point in the Cartesian coordinate system. Now the transformation for polar coordinate system from Cartesian is x is equal to r cos theta and y is equal to r sin theta. And once you do that, you get the polar form of the complex number, and that is called the modulus argument form. It's called modulus argument form because r is the modulus of the complex number. Look at the value of r. It's x square plus y square under a square root, and that is nothing but modulus of the complex number. Okay, and while calculating, make sure you go for the positive value. And then this theta is called the argument of the complex number. So we find the modulus and argument. And I'll repeat once more, this is nothing but it's just conversion of a point in Cartesian into the polar form. Okay, so I hope you wrote all these things in a piece of paper. So let's do one problem. So the first question I'm going to work out here. You can work out with me. So please write. Change into modulus argument form. Change into modulus argument form. The complex number z is equal to 1 plus I root 3. Change into modulus argument form. The complex number z is equal to 1 plus I root 3. So friends, remember, the modulus argument form is nothing but r into cos theta plus I sin theta. So we start like this. Let 1 plus I root 3 be equal to r into cos theta plus I sin theta. And you can call it equation number 1. Remember, our aim is to find r and theta. R is very easy. You take the positive value of the square root of 1 square plus root 3 the whole square. So look at this. We have the complex number 1 plus I root 3. And that's basically the coordinate 1 comma root 3. So what's the formula for r? R is the positive value of root under x square plus y square, or the modulus of the complex number, and we get 2. I'll repeat, go for the positive value. Okay, so I'm going to call it equation number 2. Okay, now what we do is we find phi. Yeah, I know we have to find theta, but the first thing to do while doing a numerical is we find phi, so that it will be very easy to find theta. And phi is nothing but tan inverse modulus the y coordinate. What's the y coordinate here? Yeah, root 3. The whole divided by 1. Anyway, Both of them are positive, so the modulus is the same as root 3. So I get tan inverse root 3. And what is tan inverse root 3? Okay, that is 60 degree. And I'm sure all of you learned trigonometry before you started complex numbers. So let's write 60 degree in radian measurement, that is pi by 3. Now I want you to take a look at that chart. Okay, this will be more clear. Okay, so take a look at this. I hope you're noting these things down. So if the complex number is in the first quadrant, the value of theta will be 5. If it is in the second quadrant, it will be pi minus 5. In the third and the fourth quadrant, it will be exactly negative of the value which is above the x-axis. Okay, so so we know the value of r and we know the value of 5. One last thing, the given number, the given complex number has symbol positive and positive, has a sign positive, positive. That means our complex number is in the first quadrant. In the first quadrant, theta is the same as 5. So what's the value of theta? Pi by 3. Okay, so that will be equation number 3. Okay, so if you use equation 1, 2 and 3, we get the answer. And what's the answer, my friends? 1 plus I root 3 is equal to, what's the value of r? 2. And what's the value of theta? Pi by 3 plus I sine pi by 3. So this is our modulus argument form or modulus amplitude form or the polar form. Okay, let's try one more numerical. Okay, so please write the question, the second question. Put into polar form the complex number -1 minus I. So I'll repeat the question once more. Change into modulus argument form or the polar form the complex number z is equal to -1 minus I. Okay, now can you tell me the Cartesian coordinate of this number? Okay, -1 minus 1. Okay, I'll go back to black. Okay, so first you must write let -1 minus I. What's the polar form or the modulus argument form? Okay, r cos theta plus I times sin theta. So remember, we have to find r as well as theta. Finding r is really easy. You take the positive value of -1 the whole square plus -1 the whole square, and we will get root 2. Okay, so I forgot to put equation number 1, equation number 2. Okay, now let's go for the next thing. I know we have to find theta, but what do we find first? What do we find? Yeah, phi. And phi is tan inverse modulus of, what is the y value? Yeah, -1 by -1. And when you take the modulus, we get tan inverse 1. And tan inverse 1 is 45 degree. And in trigonometry, you learned that this will be equal to pi by 4 radians. Okay, now let's go for the Cartesian system. Our complex number in the Cartesian system is negative, negative. That means it's in the third quadrant. I want you to check the chart. In the third quadrant, theta is minus of pi minus 5. Okay, so what's the value of theta? it will be minus of pi minus pi by 4, and that gives you minus 3 pi by 4. So I'll call it equation number 3. So when you use 1, 2, I'm sorry, it looks like 3, but it's 2 and 3, we get, so what do you get? What's the answer? Yeah, minus 1 minus I. I want you to focus on equation number 1. I want you to focus here. Is equal to, what's the R value or the positive value of R? Root 2. And then cos minus 3 pi by 4 plus I sine minus 3 pi by 4. If you want, you can keep it like this, or you can simplify using these relations from trigonometry. What is sine minus theta? Minus sine theta. And what is cos minus theta? That will be cos theta. So if you want, you can simplify this part. Okay, let's do one more question, and that will be the last question. And with that, we will end this video. Okay, so please try this one. Put into modulus argument form the complex number minus 1 by 2 plus I root 3 by 2. Okay, so let's say let this number be equal to R into cos theta plus I sin theta. So what's the aim? What are we trying to find? Yeah, R as well as theta. Okay, so tell me, what is the R value? R is equal to root under x square plus y square. By the way, what is x and y over here? Yeah, minus 1 by 2 and root 3 by 2. So did you get the value? I'm not going to simplify, so I'm waiting for your answer. Okay, I hope you got the value 1. Always remember, use the positive value. Okay, now don't find theta directly. Don't try to find theta directly. Use the shortcut. So go for phi. And again, I'm waiting for your value. You know the value of phi. Anyway, I'll write it once more. Tan inverse mod y by x. And I hope you got the answer pi by 3. Did you get pi by 3? Yeah, that's nice. Okay, now the last thing to do, draw our quadrants, and you can see that our number is negative, positive, and x being negative and y being positive means second quadrant. In the second quadrant, theta is equal to pi minus phi. So what's the value of theta? Did you simplify? And did you get 2 pi by 3? Okay, that's really nice. Now that's it. I'm not going to explain anymore. You have R, you have the value of theta. So go ahead, substitute, and you have the modulus argument form. Okay, so I'll be making a new video which is related to more numericals and complex number. So till then, bye.